Our EOC review today is quadratic applications. The first one we're doing is the dimensions of a rectangle. If your area is 75 square feet, start by drawing your shape. And then how do you find area of a rectangle? Multiply the outside. So length times width equals your area. So our length and width are expressions. So we're going to multiply those and keep it in parentheses just like they did here. So x minus 3 is going to get multiplied to x plus 7. And that's going to equal the area of that rectangle. So 75. The normal way you would solve this if you weren't going to use Desmos like we are is to FOIL this out. We go first x times x. So x times x first is x squared. Outside x times 7 is 7x. Inside is negative 3x. I'm multiplying, and negative 3 times 7 is negative 21. Simplify it and set it to equal to 0, and then solve by quadratic formula or by graphing. Combine like terms. 7 minus 3 is 4. I'm just trying to put it in standard form. So standard form is your ax squared plus bx plus c equals 0. So we have to set it equal to 0. So we have to move the 75 over the equal sign. So I'm going to subtract 75. And make sure you're subtracting it to the other constant on the other side. So I'll get x squared plus 4x minus, if you're doing two negatives, you add them. So you should get 96 equals 0. So from here, you can factor. You can use the quadratic formula to solve. You can't use square root because there's an x, or you can graph. And I'm suggesting graphing, guys. So we're going to go to graph. So Desmos.com. I'm going to keep going to the tool practice so you see the exact version of our South Carolina standard test graphing stuff. X squared plus 4x minus 96. Zoom out. There we go. And zoom back in. Okay. Oh, you even put equals 0. Not looking. So our answers are where you cross your x-axis, your roots, your solutions, all of that. So where we cross our x-axis. So we have two answers, negative 12 and 8. So x equals negative 12 and x equals 8. Now the difference with word problems, like if this was just a straight up quadratic, solve this, what are your two answers? Those are your two answers. But this says, what is the dimensions of the rectangle? So we're talking about like the width and the height. If you plug negative 12 in, that's saying the length of this is negative 15 feet. And then the length of this one would be negative 12 plus 7 is 5, right? Negative 5. You can't have a negative length and width. So it's not going to be 12, negative 12. It's just going to be 8. So usually it's the negative one's not going to be your answer, but sometimes these equations will have it be negative. But you can always check your answer. So if x is 8, like I'm saying it is, 8 minus 3 is 5. And 8 plus 7 is 15. And 5 times 15 is 75. So we know we got the right one. Because if I multiply them, I get an area of 75. And that's what we were looking for. If this was a multiple choice question and they gave you like x plus 8, x plus, x equals 7, x equals negative 12 would be an option. And then sometimes they'll even put 8 and negative 12. And you can just work backwards and plug them in your answers and see which one multiplies to 75. Okay, last thing I'm going to say on this question, because I know I'm harping on it a lot. We did not need to solve. We did not need to factor and do all of this. We can put this in Desmos right away. Why I took the time to solve it is because if you're not using Desmos and you're using a regular graphing calculator, you have to solve for it and set it equal to 0. So you'd have to have y equals if you're graphing it in any other calculator but Desmos. Desmos is great, where'd it go? Because I don't need to solve. X minus 4, x, plus 7. I was wrong. Plus 7 minus 6 equals 75. And then your zeros are your answers. So this question is very simple. Once you know you're multiplying your two sides, setting it equals 75, I graph it. Where it crosses the x-axis are my solutions. Make sure you know the negative 12 doesn't make sense, so you get rid of that one. All right. Next question. The stress distribution of a structure is given in this equation, where S is the stress in pounds per square inch and X is the distance in feet from a reference point. What distance is the stress equation to 0 pounds per square feet? I tripped over reading that. That was a lot of words. So I personally don't like switching S. I like to stick with X and Y. I think that helps. So I'm just going to change my S's to Y's. What is the distance? What distance is the stress equal to 0? So we're looking, our answer is going to be the distance. Our answer is going to be a distance. And X is the distance. So our answer is going to be X. Right? X is the distance. Y is the stress per pounds. So knowing stress per pounds is 0, so this is saying Y equals 0. What is X? So I think the hardest part of this question is, what is it asking? So that's why X is the distance in feet. What distance means we're finding X. Y is the stress in pounds per square inch. It gives us that, the stress equation to pounds per square inch. And then we can just graph our equation. So when we graph our equation, we're trying to find out the point where y equals 0. Or another name for that is your x-intercept. So we'll graph it in Desmos. 2, 4, -3. 2, 4, -30. Oops, that would be the wrong answer. -5 and 3, two different answers. -5 and 3. -5. But we're talking distance. So 3. Can't be this one. It's 3. What is the distance? 3 is the distance in feet from reference point. So 3 feet. Distance can't be negative, so that's why it wasn't -5. It's just 3. I'll get my pants. I can't drink. So those word problems are a little bit more application than what we were doing. We just did projectile motion, which is like 52. So 52 is more common. That's what we practice. But you could see other questions like 51 and 50. A toy rocket is launched from a platform of 48 feet. The rocket height above the ground is modeled in this. What is the height at 2 seconds? So the biggest thing you have to know about these questions is you can't plug t into Desmos. Because you have to put x in. Because this is x and y. So I could not, if I put t in, I'll just t and t. It's nothing. You won't get a graph. So you have to put the x. -16 x squared 32x plus x and y is what you have to put. And then I go home, get zoomed in a little bit. Okay, so I'm looking for 2 seconds, and I am very far zoomed out. So you can trace it until you get to 2 seconds, but this is the hard way to do it because you have to like go back and forth until you get to 248. We're saying when x is 2, so x is 2 up here. The easiest way to do it is not to label this y and use your function notation. So instead of y, we're going to say f of x. And then remember, we can create a table. And instead of letting this be y, we're going to now say this is f of x. And whatever number I want it to be. So x1. You want to know at 2, it's 48. Or you can just, after you label it f of x, you can say f of 2 is 48. I would only use the table if I was going to find multiple numbers. Like if I was going to find a table to graph it myself, I'd use the table. But since I'm just finding 2, I do it this way. So 48. 48 feet. Feet. Yep. 48 feet. I showed a lot of work there, didn't I? So, just so if you look back on these before your ESE, what we did is we plugged in for h of x, we made f of x, we made t x squared, And then we were just finding f of 2. We're trying to figure out when x is 2, when it's 2 seconds, we got 48. That's what we did in the calculator. Oh, before I stop this video, that's one question at the height. I also want you to remember if it says, when does it hit the ground? Hit ground. Those are your roots, your zeros, your x-intercepts. You're looking for your x-intercept. Remember, if it talks about the maximum height, that's your y of the vertex. If it asks for the maximum, the time it reaches the maximum height, that's the x of your vertex. Remember, x is time, y is height. All right.